There are very few off-grid solutions that can simultaneously heat a home, provide hot water, and generate electricity from a single system. This is one of those rare setups. Unlike a photovoltaic solar array, this system can be built, operated, and maintained with basic mechanical skills, and all it needs to run is a stack of wood. This system is called a gasifier. It is a technology that humanity has relied on during some of its toughest moments, keeping industries operational, vehicles moving, and homes illuminated when all other conventional methods had failed. In the following minutes, you will learn how gasifiers work, why they achieve over 50% greater efficiency than standard combustion systems, and most importantly, how you can integrate one into a self-sufficient setup. To grasp the impact of the gasifier, we must travel back to a period before natural gas pipelines existed, a time when smoke was becoming a severe problem. In the late 18th century, cities expanded rapidly, and coal burning for residential heating and industrial use surged. Major urban centers, including London, were already suffering from thick, choking pollution. In 1792, a Scottish engineer named William Murdoch conducted controlled experiments to address this issue. He discovered that heating coal or wood in a sealed vessel without oxygen did not just burn the material. Instead, it released a flammable vapor that could be transported, controlled, and ignited exactly where needed, eliminating the dense smoke from incomplete combustion. Within 20 years, the London and Westminster Gas Light and Coke Company had transformed Murdoch's laboratory-scale discovery into the world's first gas utility, piping town gas throughout London to illuminate homes, streets, and businesses. As the Industrial Revolution progressed, gasification became the core of major cities across the industrialized world. For those familiar with vehicle gasifiers, this technology was especially critical during the World Wars. During World War I, gasoline shortages forced widespread adoption of town gas for vehicle propulsion, particularly in Britain, Germany, and France. Large gas bags were mounted on the roofs of cars and buses. It was a functional, if rudimentary, solution. The main limitation was energy density. Low pressure restricted travel range, sometimes to as little as 30 miles before refilling was necessary. By World War II, gasifier vehicles returned, but the technology had advanced significantly. Compact reactor designs, including the invert gasifier, allowed self-contained units to be installed directly on vehicles. At the war's peak, over 1 million cars, buses, tractors, and motorcycles ran on wood gas produced by onboard reactors. Entire agricultural and transportation networks across occupied Europe operated on fuel sourced from local timber or coals when all other options were unavailable. After the war, with cheap oil widely available, gasifier vehicles fell out of use. Town gas also became largely obsolete as the early 20th century brought massive natural methane discoveries. The energy industry gradually replaced town gas with natural gas, which was abundant, inexpensive, and safer. Before exploring how to implement a gasifier in a self-sufficient setup, it is essential to understand why a gasifier outperforms a typical wood stove. A gasifier is not merely a stove. It is a chemical reactor. In a standard fire, combustion occurs, rapid oxidation of fuel with unlimited oxygen. In contrast, a gasifier uses pyrolysis and reduction, deliberately limiting oxygen to force molecules to rearrange. The process operates through 4 distinct thermal zones. When wood enters a gasifier, the first zone, called the drying zone, removes moisture. Incoming heat drives off surface and internal water. Correct moisture management is crucial because wood with more than 20% moisture can quench downstream reactions. Next is the pyrolysis zone, where temperatures rise between 752 and 1,292 degrees Fahrenheit. With no oxygen present, the wood cannot burn directly. Instead, it breaks down, producing charcoal, tars, and primary gases. The crucial stage occurs in the reduction zone. Through a process called the Boudward reaction, carbon dioxide generated in the hot core passes through a bed of glowing red charcoal. This removes an oxygen atom from the CO2, creating carbon monoxide, and also splits water vapor into hydrogen. The output is syngas, a mixture of hydrogen, carbon monoxide, and methane. This high-energy fuel burns much cleaner than raw wood. Because the reactor removes tars and soot, the resulting gas can be used in a combustion chamber to heat water for a hydronic system, piped to a gas burner for cooking, or fed into a modified internal combustion engine to produce electricity. The solid byproduct remaining in the reactor is biochar, a porous carbon that provides a permanent habitat for soil microbes and retains nutrients that would otherwise wash away. Research from the Cornell University Department of Crop and Soil Sciences confirms biochar is one of the most effective soil amendments on Earth. Gasifiers also outperform traditional combustion systems in efficiency. In 2024, studies on decentralized thermochemical systems revealed that a small-scale downdraft gasifier could reach over 80% thermal efficiency, far above the 30 to 40% efficiency of an open fireplace, while emitting up to 90% less particulate matter. Fuel economy is equally impressive. Research from All Power Labs shows that 2.2 pounds of dry biomass generates roughly 88 cubic feet of syngas. For a homeowner with timber access, a single cord of wood, approximately 128 cubic feet, contains enough chemical energy for months of cooking and supplemental heating. For those seeking to lower their energy footprint, the Rice University Baker Institute for Public Policy found that gasification can be carbon negative. The biochar produced is essentially pure carbon absorbed by the tree from the atmosphere. And because it is buried in soil instead of released into the air, the system removes more carbon dioxide than it emits. This also benefits the surrounding habitat. USDA Forest Service research indicates biochar can increase soil water retention by up to 28.5% and reduce nutrient leaching by up to 28%, keeping nitrogen and phosphorus available to crops instead of losing them to runoff. With a sustainable feedstock cycle, gasification can lock 50 to 80% of the feedstock carbon in a stable form that remains in soil for centuries. The evidence shows gasifiers provide energy independence in an accessible, non-destructive way. Yet several factors make it unlikely they will regain wartime-level popularity. The most obvious challenge is supply. A wood gasifier requires a continuous, substantial flow of dry biomass. Meeting the full heating, hot water, and electricity needs of an average American home requires multiple cords per year, necessitating access to a commercial biomass source or land for true self-sufficiency. Concerns about deforestation often arise with biomass solutions. However, gasifier fuel does not require clearing ancient forests. Coppicing, a woodland management method used for at least 10,000 years across Europe and Asia, involves cutting species such as hazel, oak, ash, and willow back to the base or stool at ground level. Because the root system is already well established, regrowth is often faster and more energetically dense than the original tree. Cutting the stool on a rotation of 7 to 15 years, depending on species, allows continuous harvestable wood without killing the tree, clearing land, or reducing the woodland's carbon stock. In England, traditionally managed coppices have been harvested from the same stools for over 500 years. Coppicing also permits sunlight to reach the forest floor, supporting far greater species diversity than unmanaged closed canopy forests. For those without land access, gasifiers can still be used for supplemental heating and cooking with sustainably sourced wood pellets or local cordwood, though the economic and self-sufficiency benefits are reduced. A second limitation is convenience. A natural gas connection delivers heat instantly. A gasifier, by contrast, requires pre-cut and dried fuel. While it produces minimal ash compared to a conventional stove, the ash pit must be monitored. If the grate clogs, airflow stops, and the chemical process fails. This is an active system, not passive. The third barrier is bureaucracy. Both the National Fire Protection Association and local building code offices generally prevent gasifier installation in American suburbs. Uniform mechanical codes and utility protection rules assume any unvented gas production is hazardous. In reality, a gasifier is a negative pressure system. Gas is drawn through the reactor by the vacuum of the burner or engine, so leaks pull air in rather than allowing gas to escape. It is inherently safer than a pressurized natural gas line, where a single crack can fill a house with explosive vapor. For those with a reliable fuel source and the motivation to manage a gasifier, multiple options exist depending on skill and technical requirements. In America, the simplest entry for high-efficiency home heating is a wood gasification boiler. Unlike a standard stove, these units have two chambers. The top gasifies the wood, while the bottom burns syngas at over 1,832 degrees Fahrenheit. For homeowners with a large wood lot, these boilers are ideal. A certified unit costs between $4,000 and $7,000, but typically pays for itself in wood savings in under 5 years. In Europe, for domestic living room performance, the Waltherm Vajolet range represents the benchmark. These precision-engineered gasifiers use a downdraft combustion process. Wood gas passes through a glowing bed of coals into a secondary combustion chamber, mixing with preheated air and reaching a 93% efficiency rating, the highest recorded for a wood-burning appliance. Homesteaders seeking electrical generation alongside heating often use a downdraft gasifier feeding a modified internal combustion engine. Using stainless steel vessels, often repurposed from beer kegs or heavy gauge pipe, a reactor can feed a standard gasoline generator. Technical details are documented in Ben Peterson's Wood Gasifier Builder's Bible and Stephen Honkas's Wood Gasifier Builder's Workshop. Factory-built automated kits are also available from companies like All Power Labs for those seeking engineered solutions. With sustainable fuel and proper implementation, a home gasifier can generate a self-regulating stream of power without reliance on the grid, utility companies, or the failures common to modern energy systems. Please leave your thoughts about this content in the comments below. Thanks for watching. See you in the next one.